So we're going to continue what we did yesterday with factoring these trinomials. You can just have a seat in here. So again, these trinomials are said to be in the form ax squared plus bx plus c, where c equals 1. A equals 1. So a is the number in front of the x squared. Okay, so all the ones that we've done so far yesterday, the number in front of the x squared was a 1 because there was no 1 written there. We did some where the number in front of the x squared was a 2 or a 3 using algebra tiles. So we did that using algebra tiles, but now we're going to do these by using what's known as factoring by inspection, by looking at the trinomial and figuring out what the two factors are. And so this first question says factor if possible, because not all of these can be factored. Sometimes you'll see ones that won't be factorable. But on a quiz or a test, if you're asked to factor something, there will be factors. Okay? So the first one, we want to factor x squared plus 5x plus 4. First thing you always look for is a common factor, and there is none. So if factors do exist, they will be binomial factors. The front terms have to multiply together to get this x squared. And because of that, you'll need an x in each bracket. Okay? You cannot put an x squared in the first bracket and a 1 in the second. It won't work. You won't get the original trinomial when you multiply those out. And then remember, we're now looking for two numbers that multiply together to get the constant term and add to get that initial or that middle term coefficient. So the numbers that multiply to get plus 4 and add to get plus 5 will be positive 1 and positive 4. You could put the 4 in the first bracket, the 1 in the second. It doesn't matter. But we're saying those are the factors. And remember, you can always check by multiplying. Use the distributive property. And that'll give us x squared plus 4x plus 1x plus 4. When you add the 4x and the 1x together, you get the middle term 5x that you needed. So we have just checked our answer. Our factors are correct. Remember, factors are things that multiply together to get what you start with. When you multiply x plus 1 and x plus 4 together, you do get the original trinomial. So those are the correct factors. All right, looking at question B. It's x squared plus 4x plus 6. There is no common factor there. So if factors do exist, they will be binomial factors. And we're looking now for two numbers that multiply together to get 6 and add together to get 4. Again, you need an x in the first position of each binomial because x times x will give you the x squared here. But to know what numbers go after the x's, we find two numbers that multiply together to get 6 and add together to get 4. And in this case, there are none. Okay, you can go 1 times 6 to get 6, but whether you add or subtract the 1 and 6, you don't get 4. You can also go 2 times 3 to get 6, but no matter what you do to the 2 and 3, they don't equal 4. Add them or subtract them won't work. There are no more factors of 6. So in this case here, there are no factors. Sometimes you're going to see that. Not on a quiz or a test, though. Okay? On a quiz or a test, if you're asked to factor a polynomial, it will be factorable. Question C. X squared minus 29x plus 28. There is no common factor there. So if factors do exist, they will be binomial factors. So Brock, what goes in the first spot of the binomials? Have you copied down the first two examples that we did together? I've talked to you about that already, right? Yes? Okay, you need to copy it down. So get it copied down. And I'm going to check. And if you don't have everything copied down, then you're going to be coming in here at lunchtime on Monday to do it. Okay, so those are your options. You just can't sit there and do nothing. Pardon me? But you're not even doing that. When I called your name, you were looking down at your paper and you were doodling on it. You weren't paying attention to what I was doing. Pardon me? Well, you had your pencil and you were doing something like that. So you were not paying attention. So again, I'm going to check at the end of the class to make sure you've got everything copied down. And if not, you'll be here Monday at noon. I will go right ahead. So what are we looking for now? Sherry? Right, negative 29. But yes, absolutely. Multiply together to get that last number, add to get the middle term coefficient. So because they multiply to get a positive value, their signs have to be the same. And because they add to get a negative value, they both need to be negative. The answer is here, the numbers that'll work will be negative 1 and negative 28. They multiply to get positive 28, they add together to get negative 29. So there's your factors. We think. How do we know for sure? Well, we check by multiplying. So using distributive property, that's what we're doing here. X times x gives us our x squared. X times, whoops, yeah, that's right. X times negative 28 is negative 28x. Negative 1 times x is minus 1x, and negative 1 times negative 28 is positive 28. You've got the x squared. Negative 28x, take away 1x is negative 29x. And then we have the plus 28 at the end. It works. How can you relate, Liam? Did you sign in? Thank you. So we've just shown that our factors are correct. They do multiply together to get what we started with. Now, question D, we haven't seen any like this before because this one has two variables in it. The first term is x squared, the middle term is positive 3xy, and the last term is minus 18y squared. There is no common factor here. The first two terms have an x, but the last one doesn't. The last two terms have a y variable in it, but the first one doesn't. There is no common factor here. So once again, if there are factors, they will be binomial factors. The front terms will multiply together to get x squared, so you need x's in the first position, like we've been doing all along. But because the last term is minus 18y squared, so part of that term is the y squared, which means we need to have y's in the second position of each binomial. The rest of it is done exactly the same. We're looking for two numbers that multiply to get negative 18, add to get positive 3. And the numbers that work there would be positive 6 and negative 3. They multiply to get negative 18, they add to get positive 3. So positive 6 and negative 3. And to make sure that they are correct, again, we will multiply them out using the distributive property. So x times x is x squared. X times negative 3y is negative 3xy. 6y times x, and that is 6yx or 6xy. When you multiply, order doesn't matter. And the reason I wrote it in that order is because that matches the order of the previous term. And then 6y times negative 3y is negative 18y squared. So we'll get x squared plus 3xy minus 18y squared, which is what we started with. So we have just shown that our factors are correct. They work. They do multiply together to get what you start with. Okay, our factors are correct. So on the next page, it says factor if possible. The first one, we've got a trinomial there. There is no common factor, so if factors exist, they will be binomial factors. The front terms multiply to get x squared, which means we need an x and an x. Now what are we looking for, Declan? Multiply to get 10 and? Can you think of two numbers that do that? What about their signs? Yes, they multiply to get positive 10, so their signs have to be the same. They add to get a positive 7, so that means they both have to be positive. What do we do now, Keen? We're going to multiply to check. If those are the factors, they will multiply to get the original trinomial. So x times x is x squared. We're going to have a 5x. We're going to have a 2x. And we're going to have a 10. 5x and 2x add together to get 7x. That's the original polynomial, the original trinomial. So we've just shown that our factors are correct. They work. They do multiply together to get what we started with. Question B. This is another one of those ones where there are two variables in there. There is no common factor amongst all three terms. So if there are factors, there'll be binomial factors. The front terms multiply together to get r squared. So you need an r in the first position of each binomial. The last term is 9s squared. So each binomial will have to have an s in the last position. That's where the s squared will come from. But then we need to know what two numbers multiply together to get plus 9 and add together to get negative 10. And the numbers that work there would be negative 1s and negative 9s. Negative 1 times negative 9 is positive 9. And when you add negative 1 and negative 9 together, you do get negative 10. So those should be the factors. And to check, again, we will multiply. So you're going to get r squared minus 9rs minus 1rs. Again, s times r is the same as r times s, plus 9s squared. When you collect those inside terms, negative 9rs, take away one more, will give you negative 10rs's. So that is the original polynomial. We have just shown that our factors are correct. They work. You don't need to have a 1 in front of the s. I put one there just so we were clear about what that term represented. You can just say r minus s and r minus 9s. So remember, the first thing you always look for is a common factor, always when you're factoring. And there is a common factor for c. The common factor is 2. That's one of our factors. To get what's inside the bracket, we divide each term by the common factor. But you have an initial factor of 2, and this must be part of your final answer. When you're factoring, you must have a common factor or a factor of 2 as part of your final answer. So we took out a common factor of 2, and we're left with this trinomial inside the brackets. So if it can be factored further, they would be binomial factors. And we're looking for two numbers that multiply to get negative 24, add to get positive 5. And the numbers that work there would be positive 8 and negative 3. But first, we're going to have an x in the first position, and then we'll have the positive 8 and the negative 3. You could have the negative 3 in the first bracket, the positive 8 in the second. It doesn't matter. So we're saying that those are our factors. And if they are, that means if we multiply this out, we'll get what we started with. Because there are 3 factors here, we'll work our way left to right by first multiplying the 2 by the x plus 8. That'll give us 2x plus 16, which is then multiplied by the x minus 3. So I multiply both the x and the 8 in that first bracket by the 2 in front. That's where the 2x plus 16 came from. And now we need to use distributive property to make sure that we get the original trinomial. So I'll get 2x squared minus 6x plus 16x minus 48. Negative 6x plus 16x is positive 10x. That matches the original polynomial. So these are the correct factors. There are 3 factors for that one. 2, x plus 8, and x minus 3. Okay, question D. There is a common factor there of 3. And to get what the other factor is, again, you divide all of the 3 terms by the common factor of 3. And now we're going to see if we can factor the trinomial that's inside the brackets. If there are factors of that, they will be binomial factors, so we put down our brackets. The front terms have to multiply to get d squared, so therefore they both have to be d's. And now we're looking for 2 numbers that multiply to get negative 12 and add to get negative 1. That negative d is negative 1d. Yes. Where did I get the 12? By dividing all the terms by 3. That's our common factor. 36 divided by 3 is 12. So 2 numbers that multiply to get negative 12 and add to get negative 1. Yes, Jan? They do multiply to get negative 12 and they do add to get negative 1, so they should be correct. But we will multiply out to check. Again, there's 3 factors here, so I'd multiply the first 2 together by going 3 times the d and 3 times the negative 4, which is then multiplied by the last binomial by using the distributive property. So I'll get 3d squared, I'll get positive 9d, I'll get minus 12d, and negative 12 times 3 is negative 36. When you combine those d terms together, 9d take away 12d is minus 3d. So that matches the original trinomial. We have just shown that our factors are correct. There are 3 of them. Yes, sir. When we're done. We won't be long. So we're going to see that sometimes you can apply factoring to help you solve a problem. The world famous Devil's Cauldron is the 4th hole at the Banff Springs Golf Course. It's a tough tee shot from an elevated tee that must carry the ball across a glacial lake to a small bowl green. The approximate height of the ball during a typical shot can be represented by this formula. H equals negative 5t squared plus 25t plus 30, where t is the time in seconds, h is the height of the ball, relative to the green in meters. Write the factored form of this formula. So that's what we're going to start with. We have h equals negative 5t squared plus 25t plus 30. Remember, the first thing you always look for is a common factor, and there is a common factor here of negative 5. we take it out, remember to get what's inside the bracket, you divide each term by the common factor. So you're going to divide all three terms by -5. So all the signs will change because we're dividing by a negative value. And that trinomial that's inside the bracket can be factored further. The front terms multiply to get t squared, so we need those t's there. And now we're looking for two numbers that multiply to get -6, add to get -5. And -6 and +1 will work. So there's the factored form of that equation. Part B wants to know the height of the ball after 2.5 seconds. So we're going to see that we can do this two different ways. The first way would be using the original equation and letting t equal 2.5. So I took the original equation, and I'm letting t equal 2.5. So we'll get the calculator out. The first term is -5 times 2.5 squared. That's -31.25. Plus, the next part is 25 times 2.5. That's 62.5. Yep. 62.5 plus 30. So now we can add these three things together. I've already got the 62.5 there, so I can add -31.25 and 30 in there, and I get 61.25. That's the height of the ball relative to the green after 2.5 seconds. So as I said, you can use the original equation to do it, or you can also use the factored form. The factored form is the same equation. It's just factored. The original one is a sum and difference of terms. When you factor it, you'll get a product of factors. So we're going to see that we're going to get the same answer by letting t equal 2.5 in this equation as well. And the other thing we're going to see is that it's a little bit easier to do this because you're only going to need a calculator really for that last step. So you're going to have the -5, and that's going to be multiplied by -3.5. That's what you get when you go 2.5 take away 6. And when you go 2.5 plus 1, that'll be +3.5. So we're going to multiply these three numbers together. And we get exactly the same answer as above, 61.25. But the factored form was a little bit easier to work with. And that's one of the advantages of factoring. It makes most equations easier to work with. Fewer calculations, especially using a calculator, are required. So this next one, it says a rescue worker launches a signal flare into the air from the side of a mountain. The height of the flare can be represented by this formula. So there's something that these last two equations have in common. They're both degree 2 equations, meaning the highest power is 2. Okay? And also the initial term, the number in front of the squared term, is negative. That is true for both of these examples. So what you're going to see, and you'll see more of this in grade 11 when you start looking at quadratics more, anytime you have a scenario where an object or something is going up in the air, it'll reach a maximum height and then it'll fall. So the last example was a golf shot. This example that we're talking about is a safety flare. You could have the same thing, let's say, if a baseball is thrown from the outfield to the infield. Put your phone away, princess. The same thing will happen. Okay, the ball is going to go up to a maximum height, and then it's going to start falling to the ground as it's traveling forward. Well, that equation will have the same characteristics as these ones, where the number in front of the squared term will be negative. Okay, Or maybe it's a football being kicked or thrown. Again, the path of that ball will follow a path that can be represented by this type of equation, where the highest power is 2 and the number in front of the squared term is negative. They'll all have that in common. The rest of the equations might be different, but that first part, the first term will be squared and the number in front of the squared term will be negative. So the flare follows a path that is defined by that equation. Once again, we want to know what the equation is in factored form. So I'll start by rewriting it. And we will factor this by taking out a common factor of negative 16. All three terms are divisible, Jan, by negative 16. So you'll get t squared. Because we're dividing each term by a negative value, all the signs are going to change. And 144 positive divided by negative 16, I think, is negative 9. Let's just check that. 144 divided by negative 16. Yep, negative 9. So this will be minus 9t. And then positive 160 divided by negative 16 will be negative 10. So we took out a common factor of negative 16 first. And then we have a trinomial there that can be factored further. The front terms of these binomials have to multiply to get t squared, so they're both going to have to be t's. And now I'm looking for two numbers that multiply to get negative 10, add to get negative 9. What do you think they are, Brock? No? Brody? Brody? How's it going? Who's Sally? You were talking in your sleep, talking about some girl named Sally. Who's Sally? You heard that, right, Keen? Roddy, what are the numbers? Louder. So if you multiply a negative times a negative, what do you get? So they both can't be negative. Only one of them can be negative. And because they add to get a negative 9, the bigger number must be the negative 1. Because they have to add to get negative 9. So there's the factored form. Part B, what is the height after 5.6 seconds? So we saw in the last example, we can use the original one or we can use the factored one. Let's use the factored one. It's easier to work with. When t is 5.6, you'll have 5.6 plus 1 in the first bracket, 5.6 take away 10 in the second bracket. So it'll be negative 16 times 6.6, and 5.6 take away 10 is negative 4.4. So now we'll multiply these three numbers together to get the height of the flare after 5.6 seconds. So negative 16 is the first factor times 6.6 and negative 4.4. So there's your answer. That's the height of the flare after 5.6 seconds. 464.64 feet. We're told that h is the height in feet above the ground. So again, using a factored form of the equation is usually easier to work with. Usually. Okay? All right. So remember the assignment from yesterday is due for marks. You got to get that one handed in. This one here you're also going to hand in. Look for a common factor first. There is a common factor for question 11 and question 14. Take out a common factor first. And then the trinomial that you're left with will be able to be factored further. So again, the one from yesterday needs to be handed in, and then this one as well. Yes. Okay, Brody's going first. Yes. Don't tell me what to do. Hang on. The one from yesterday is due for marks.